Alrighty, today we're talking about chemical reactions. This is the first video, and we're talking about the types of reactions and how to balance reactions. So, first thing first. There are the learning targets, don't need those. 5 types of reactions: synthesis, decomposition, single replacement, double replacement, and combustion. There's all 5. So we're going to break down each one and talk about each one does. By the end, hopefully you'll be able to recognize the 5 types. So the first one is synthesis. Synthesis. This is when 2 things are coming together. The prefix SYN means together. So if you guys want to pause the video and you can take notes, write that down, definition down in your notes. Here are some examples. The generic is A plus B yields AB. So it's 2 things coming together. 2 separate entities coming together. So here are our reactants, and AB together are products. You can kind of think of this as a deathly sickly chicken eating a worm. Now it is big and strong. There together it is a new compound. Next is decomposition. Decomposition is the opposite of synthesis in that it is coming apart. So one thing breaking into many products. If you want to think about this, you guys are in high school, prom's coming up. It's like taking a girl to prom or boy to prom. Then at prom, you realize you hate the person, and you go your separate ways. At the beginning, you guys were a couple. After prom, no longer a couple. So that is decomposition. Single replacement. Single replacement is, we're going to relate it back to prom. We have a couple, BC, going to prom. Well, the thing about BC, B's not, well, he's just not very good looking. We have hunk A over here. So what B does, B would rather be with A than C. So notice how C is single over here, and A single in the reactants, C single in the products. So we have a switch, and the definition that you guys can write down is right there. Single element on one side and a different single element on the other. So we have one single element in the reactants and a different single elements in the products. Next, double replacement. Double replacement is the flip-floppy one. So 2 compounds in the reactants, 2 compounds in the products. And if you look at the generic one, notice how we're going back to the prom analogy. At prom, going to prom, we had A and B, and C and D. Well, A would rather be with C, and B would rather be with D. So we have a double replacement, where both of them were replaced. This is normally 2 ionics. We'll be studying this one more in depth. This is where we have our precipitates forming. So we'll talk about solubility. So this one's pretty important. Next, combustion. This one doesn't really relate to prom at all. This one you guys are just going to have to memorize. What happens with combustion is oxygen is going to react with a hydrocarbon chain to form carbon dioxide and water. So you guys might recognize this from burning gas. So this is how cars go. This is how cars travel, through a combustion reaction. There's a lot of energy released, and water and carbon dioxide are always our products. So they are always our products in a combustion reaction. Alright, take a minute, pause the video, go ahead and complete these on your own. just label what type of reaction it is. We'll do the first one together. So what you guys want to do when you're tackling these is notice if there's a couple, so if there's two elements or if it's just a single element. So in this first one we have Na and Cl. There's a couple right there. We also have H and sulfate, another couple. So because we have two couples in the reactants, we can already tell that it's going to be a double replacement. We have the Cl and the sulfate are going to switch. And so sodium is now going to be with sulfate over here, and the H is going to be with the Cl over here. So this is a double replacement. So go ahead, pause it, and complete this on your own. Alright, let's talk about balancing equations. Balancing equations, the next step, very, very important. So some things that you guys need to know. The coefficient. The coefficient is the number in front of the compound. So our coefficients over here is 2 for HCl, and over here it's 2 in front of NaCl. So now with balancing, we have this law of conservation of mass. So if you want to write this down, go ahead. So what it is, mass must remain constant throughout a reaction. Mass cannot be gained or lost. So basically what balancing equation is, we have to balance all of the elements. So we can't have more sodium in the reactants than the products. The amount of sodium on each side has to be equal to one another. So let's do some examples. We'll do 2 examples and then you'll be on your own. So the first thing I like to do is where the yield sign is, I like to separate the products and the reactants. So I just draw a straight line down the middle. We have our products over here. Just kidding, we do not have our products over there. We have our products over here and our reactants over here. Alright, so now the next step is to figure out to write all the elements on each side. So on our reactants we have sodium, Na. Right now we have one of those. We also have bromine. We have one of those. Now we're moving on. Hydrogen. Now for this hydrogen, we have 3 because of this subscript right there. We have 3. Next, what we could do, we could separate this P and this O4, but we also know that PO4 sticks together right there. So we're going to keep it together. We're going to try to keep polyatomic ions together. That just makes it a little bit easier when we're balancing. In PO4s, we only have one of those. Now be careful, we do not have 4 PO4s. This is a polyatomic ion. Alright, now we're going to do the same thing in the products. Make sure everything balances. Na. We have a total of 3 sodiums on this side. Right there. So we have 3 phosphates, PO4. We still only have one of those. Hydrogens, we have 1. And bromines, we have 1. Now we have to see what does not match, because we need everything to be balanced. It's kind of like a scale, an old-fashioned scale. So we can see Na. We have 1 over here, 3 over here. We are not balanced. So what we have to do is we have to put a coefficient over here so that it's balanced. So the coefficient that we need to put over here is a 3. So we can put a 3. Now we're going to go through and change our numbers over here so that they now represent the correct number with the coefficient. So 3 times 1, 3. So we have 3 sodiums. Bromines, we now have 3. So what this is saying is that we have 3 NABRs. So if you want, you can think of it like this. So 1, 2, 3 sodiums, 1, 2, 3 bromines. Alright, are we balanced? No, we are not. Notice how bromine and hydrogen are still off. So let's fix the bromine first. So we're going to come over here, and we know that we need 3 and we only have 1. So we need 2 more hydrogen bromides. We're going to put 3 there. 3. Now we have 3 hydrogens. Now we check to see if we are balanced. 3 sodiums on the left, 3 sodiums on the right. Good. 3 bromines on the left, 3 bromines on the right. Good. 3 hydrogens on the left, 3 on the right. So we're good. 1 phosphate, 1 phosphate. We are golden. This is a balanced equation. You guys have just balanced your first equation. We'll do one more together, and then you will be on your own. Alright, same thing. Draw a line separating the reactants from the products. Reactants, products. Alright. Now, nitrogens. How many nitrogens do we have on the left? Right now we just have 1. How many hydrogens do we have on the left? 3. And I's, we have 2. Right. Now to the products. Nitrogens. Dose. Iodines. 6. I don't know 6 in Spanish. Siete, maybe. Hydrogens. Dose. Right there. So we're counting the subscripts. Figure that out. Alright, now we can balance. So the first thing, let's just balance our nitrogens. So we know that we need another NH3. So that means we put the 2 there, because we have 2 NH3s. So this nitrogen becomes 2. This hydrogen now becomes 6, because we have 3 in the first one, 3 in the second. 3 plus 3 is 6. You can also do 2 times 3 is 6, same thing. Alright, are we balanced? No, we are not. So let's balance the hydrogens next. It doesn't really matter which one you balance, I'm just choosing hydrogen because it's there. So we have 6 in the reactants, 2 in the products. So if we add 1 more H2, we now have 4. Are we balanced? Negative Nancy. So we gotta add another one. So now we have a total of 6. Are we balanced? Yes, ma'am. So we put a 3 there, and we're good. Now are we balanced overall? Nope, not yet. Notice our iodines are not balanced. So we're going to go ahead and do that next. So we have more iodine in the products than the reactants. So what we have to do, we have to add more I2s. So that we have a total of 3 I2s. This becomes 6, and we are balanced. Donezo. Alrighty, that is balancing equations. Go ahead and complete the rest on your own.